Retries are not a failure strategy. This is the workflow you'll know how to run when we're done. Which retries jobs, moves failures to a dead letter queue, and safely replays them. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. LLM pipelines run many small jobs. Some jobs fail because of flaky network, timeouts, or toxic prompts. You want automatic retries for transient issues. You also want a safe place to quarantine hard failures, so they do not block the whole pipeline. Success looks like steady throughput, a small manual review list, and no poisoned prompts slipping into production. At a high level, a dead letter queue is a quarantine for jobs that retries cannot fix. Imagine a conveyor belt where items are rechecked a few times. After a certain number of attempts, the bad item is moved to a labeled bin. A human or a safer automated step then inspects and fixes the item before putting it back. This reduces repeated churn and makes debugging much easier. We will build a small Redis Streams based workflow. It seeds a few example jobs, runs a simple consumer that acts good outputs, finds stuck messages that exceeded retries, and moves them to a dead letter stream, shows a safe replay path where an operator sanitizes a prompt, and finally runs a guarded worker that enforces a safety check. Keep in mind, this is a toy pipeline to demonstrate the patterns. Now we start with the first asset. This snippet connects to Redis with redis-py and prepares a job stream. The variable client is a Redis connection, and main DLQ and group name the primary stream, the dead letter stream, and a consumer group. The call xgroup create makes a consumer group on the main stream, and mkstream ensures the stream exists. 3 toy jobs are inserted with xadd, so we have visible work items, including one intentionally problematic prompt. Finally, xlen counts the backlog for a quick sanity check. The printed job seeded value confirms the initial queue depth you will process next. The snippet sets up the exact names and a few seed records, so the rest of the walkthrough has concrete items to operate on and verify. Next, we consume new visible jobs and exercise acknowledgements. This example consumes new messages from the main Redis stream using xreadgroup with consumer C1. The dictionary main.n tells Redis to deliver only unseen entries to this consumer. Inside the loop, the variable PR holds each prompt, decoded from bytes. When the prompt does not include the word bad, the code acknowledges it with AX and increments the OK counter. Messages that are not acknowledged remain pending in the group, which simulates a failure without clogging the visible tail of the stream. The printed act OK value shows how many items successfully advanced past the worker. This part demonstrates a typical worker that retires or leaves items pending when it cannot process them, which is important so the DLQ logic can later find stuck messages. Next, we identify messages that have been delivered too many times and should be quarantined. This snippet inspects the consumer group's pending entries with xpending range to find messages that have been delivered too many times. The variable max retries sets the cutoff. Entries whose times delivered meet or exceed it are selected. For each selected message, xrange fetches the original fields so we can preserve context. The code adds a reason field and writes the entry to the DLQ stream with xadd, then acknowledges the original on the main stream using xack to prevent reprocessing. Increasing max retries permits more automatic retries, but risks queue churn. Decreasing it isolates failing jobs faster. The printed moved to DLQ confirms how many failures were quarantined. This step turns invisible pending traffic into an explicit reviewable queue. Next, we show how to safely replay a quarantined job after sanitizing it. This example pulls a single message from the DLQ using xread and prepares it for a controlled replay. The tuple mid data holds the entry ID and its fields. The data variable is copied and then sanitized by replacing the prompt with a safe value to prevent poisoning downstream systems. A retry tag is added so observability tools can trace manual interventions. Finally, xadd enqueues the sanitize item back into the main stream and returns a new identifier captured in RID. The printed replayed ID confirms that one quarantine job re-entered the pipeline through a safe path. This shows a safe, auditable path to reintroduce previously failing work. Next, we run a guarded worker that enforces a safety rule before acknowledging jobs. This snippet runs a minimal worker that enforces a basic guardrail before acknowledging messages. The function guard checks length and forbids the word bad to prevent unsafe prompts from flowing downstream. The call xreadgroup delivers new jobs to consumer C2, including the sanitized replay. For each message, the prompt is decoded, inspected, and either processed by a trivial uppercase transform or rerouted to the DLQ with a guard reason. Acknowledgements via xack ensure the mainstream does not get clogged. Tightening the guard reduces risk but can lower throughput. Relaxing it does the opposite. The printed process now confirms a successful, safe, end-to-end pass. This final worker completes the loop and demonstrates how DLQ plus replay plus guardrails yield robust processing. In a real project, you map the toy prompts to real LLM requests and the guard function to content filters or model safety checks. The DLQ becomes your human review queue and audit trail. The same pattern scales to larger streams and distributed consumers by increasing monitoring and adding metrics around pending lengths and DLQ growth. Recap: a dead letter queue is a quarantine for jobs that retries cannot fix. Use it when failures repeat, when you need human review, or when you must prevent poisoned inputs from re-entering production. One caveat: moving too quickly to DLQ can hide transient failures and reduce throughput. Next step: tune the max retries cutoff and the guard strictness. Then measure how those choices affect throughput and DLQ size. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.